Okay, so if we look at these, we start looking at lithium and fluorine. So if we look at the periodic chart and we think about their position in the periodic chart, lithium and fluorine are in the same horizontal row. And since size is decreasing going across to the right, lithium would be bigger than fluorine. Okay, let's look at the next one. Nitrogen or antimony. Okay, nitrogen and antimony are in the same family, and things get bigger going down. So it's antimony. Cesium or chromium. Here's cesium. Here's chromium. So this is further left and further down. Antimony and bromine. Here's bromine. Here's antimony. Now, usually the question comes up, well, what if you gave us sulfur and bromine? Which is bigger? Why? That's a great reason. That's exactly correct. Okay? But usually I would not put that on the test because you would know that sulfur is bigger than chlorine and you would know that bromine is bigger than chlorine. But really, sulfur and bromine, it would be hard to say. But the best guess would be bromine because you've added that layer, kind of like adding a layer on a jawbreaker. Okay, so that would be a good guess. Okay, now, let's look at oxygen or oxide. This is the one that's harder to see because this isn't on the chart. This goes back to what we just said, that atoms losing electrons become smaller. So cations, positively charged ions, are smaller than their atoms. And atoms gaining electrons get bigger because you're adding on another area for electrons. So the oxide ion is bigger than oxygen. The sodium ion is smaller, so the sodium atom is bigger. Sulfur and sulfide, the negative ion is bigger. Now, when it gets to iron 2 or iron 3, if we think that cations are smaller than the atom it came from, the more electrons I take away, the smaller it gets. Does that make sense? So iron 2 would be bigger than iron 3. Okay, again, which has the bigger ionization energy? Well, remember, ionization energies increase from bottom to top and left to right. So we have low ionization energies here and high ionization energies up here on the right-hand side. So looking at their position in the periodic chart, sodium and rubidium are in the same family, and sodium is higher up in the family. Remember, big things have lower ionization energy. So sodium's smaller than rubidium. They're in the same family. Chlorine or iodine. Chlorine is higher up in the same family than iodine. Look up there on the chart. Palladium or fluorine. Fluorine is higher up. Rutherfordium or zinc. Now this one might have been a little bit harder because these are further apart in the chart. Here's the rutherfordium and here's the zinc, but this is lower and to the left. Which has the highest negative value for electron affinity? And again, in the lower left-hand corner, you have small positive electron affinities because things like francium don't want more electrons. Then in the upper right, where fluorine is, you have really large negative values for electron affinity. So copper, because it is to the right of titanium in the same row. Carbon is in the same column as tin, and it's higher up. And iodine is way further to the right than cesium. Cesium's on the left, and iodine is all the way on the other side of the chart and higher. So I think that explains it, and those are the kinds of questions that you might expect to see on the test in the multiple choice format. Those things would be more likely to appear in multiple choice format because they lend themselves to that type of information. And as always, the chapter summary, if you take time in your study time to go look at that chapter summary, that tells you a list of all the important concepts in the chapter. And this Tools for Problem Solving gives you a list of how to solve the problems in that chapter.